look at window heat. Window heat controls and indicator lights are located on the overhead panel. The left and right forward window heat switches control power to the left and right number 1 forward windows. The left and right side window heat switches control power to the left and right number 2 side windows and to their respective number 4 and 5 eyebrow windows. The aft number 3 windows are not heated. The green on lights illuminate when electrical power is being supplied to their respective window. Power is automatically removed and the on light will extinguish when a window reaches its operational temperature. Sun radiation can heat the windows to their normal operating temperatures, causing the on lights to cycle on and off. Power to the eyebrow windows is not monitored. The test switch is used to check the window heat circuits. It is spring-held to the center neutral position. With the window heat switches on, the power position applies full power to the windows, causing all on lights to illuminate. However, overheat protection is still active. With the window heat switches off, electrical power is removed. The on lights are extinguished. In addition to electric window heat, conditioned air can flow across the inside surface of the forward windows for defogging. The flow is controlled by windshield air knobs. The overheat lights monitor the forward and side windows. If a window overheats, the overheat light, anti-ice annunciator light, and both master caution lights illuminate. The power to the overheated window circuit is automatically removed. Placing the window heat switch to off extinguishes the overheat and on lights and resets the monitor system. After 2 to 5 minutes of cooling, window heat may be reselected on. If the overheat light illuminates again, turn the switch off. With window heat inoperative, maximum airspeed below 10,000 feet is 250 knots. The overheat position of the test switch simulates an overheat condition, and all overheat lights illuminate. The anti-ice annunciator light and both master caution lights also illuminate. Each window heat switch must be positioned off to reset the monitor system. Delamination or cracking of a windshield affects its structural integrity. The appropriate window heat switch should be turned off. A change in airplane or cabin altitude may be required. The correct answer is C. With the window heat switches on, momentarily holding the window heat test switch to power overrides the temperature controller and illuminates all the on lights. This verifies proper operation of the temperature controller. The next system is probe heat. All pitot-static probes, angle of airflow sensors, and the total air temperature probe are electrically heated. The pitot-static heat controls and indicators are located on the overhead panel. The left heaters are controlled by a switch designated A, and the right heaters are controlled by the switch designated B. Positioning the A pitot-static heat switch to on activates heaters for the left side probes, extinguishing the respective heater lights. With the B pitot-static heat switch off, the amber probe heater lights illuminate. When a probe heater fails, the respective amber probe heater light illuminates. The anti-ice annunciator light and both master caution lights also illuminate. Now let's examine the engine anti-ice system. Icing can occur when the outside or total air temperature is 10 degrees centigrade or below and visible moisture is present in any form. Engine anti-ice must be on during all operations when icing conditions exist or are anticipated. Engine anti-ice controls and indicator lights are located on the overhead panel. Each engine anti-ice system has a switch and two indicator lights. Positioning the engine anti-ice switch on opens the engine anti-ice control valve. Fifth stage bleed air, augmented by ninth stage bleed air, is used to anti-ice the engine cowl. Engine cowl anti-ice is also referred to as TAI, thermal anti-ice. The cowl valve open light monitors the position of the engine anti-ice valve. When the valve is in transit or disagrees with switch position, the cowl valve open light illuminates bright blue. When the engine anti-ice control valve reaches full open, the cowl valve open light dims. When the engine anti-ice switches are positioned off, the cowl anti-ice valves are signaled closed. The cowl valve open lights illuminate bright blue in transit and extinguish when closed. Before turning engine anti-ice on, position the engine start switches to continuous. When the engine anti-ice system senses an overpressure or over-temperature condition, the amber cowl anti-ice light illuminates. The anti-ice annunciator light and both master caution lights also illuminate. The correct answer is C. The cowl valve open light illuminates bright blue when the valve is in transit or disagrees with switch position. Now let's discuss the wing anti-ice system. The switch and lights for the wing anti-ice system are located on the overhead panel. The three outboard leading edge slats are the only part of the wing that is anti-iced. Each wing is anti-iced from its respective side of the pneumatic manifold. The left and right wing anti-ice systems are similar. Let's look at the left wing anti-ice system in detail. The wing anti-ice switch has two positions, on and off. The switch controls the wing anti-ice valve. When the switch is off, the valve is closed. When the wing anti-ice switch is on, the wing anti-ice valve is open. The bleed air passes around the slats and is dumped overboard. The wing anti-ice valve position is monitored by its blue valve open light. They operate like the engine anti-ice valves. When the valves are in transit or disagree with switch position, the valve open lights illuminate bright blue. When the valves are full open, the lights are dim. The lights are extinguished when the valves are closed. The wing anti-ice functions in either the air or ground mode as determined by air-ground logic. On the ground, with both thrust levers less than 30 degrees and temperature in the duct below the limit, bleed air is applied to the wing leading edge slats. If either thrust lever is greater than 30 degrees or the temperature above the limit, the wing anti-ice valves will close. When both thrust levers are reduced to less than 30 degrees and the temperature is below the limit, the wing anti-ice valves will reopen. With wing anti-ice on during takeoff, the valves will automatically close as the thrust levers are advanced beyond 30 degrees. The wing anti-ice switch will trip to off when air logic is sensed. In flight, the wing anti-ice control valves will open when the wing anti-ice switch is positioned on. Duct temperature and thrust setting logic are bypassed in the air mode. Should a wing anti-ice valve not reach the commanded position, its valve open light will remain illuminated bright blue. Answer A is correct. The left wing anti-ice valve is not closed and disagrees with the switch position. The L valve open light is illuminated bright blue. The primary method of operating the wing anti-ice system is as a de-icer. Structural ice is allowed to accumulate prior to using wing anti-ice. Ice accumulation can be detected on the windshield wiper arm, window frames, or windshield center post. Using wing anti-ice as a de-icer provides the cleanest airfoil surface with minimum thrust or fuel penalty. The secondary method is to use wing anti-ice prior to ice accumulation or anti-ice. Turn on wing anti-ice prior to extended operations in moderate to severe icing conditions. The thrust and fuel penalties are high with wing anti-ice on. This next section of ice and rain protection covers rain removal. Controls for the rain repellent and windshield wipers are located on the overhead panel. A 4-position selector controls the 2-speed electric windshield wipers. The park position stows the wipers at the bottom of the windshield. Do not use windshield wipers on a dry windshield as scratching may result. The rain repellent container is located on the aft bulkhead behind the captain's seat. The rain repellent container has a sight gauge for checking fluid and a manual shutoff valve. Pushing the rain repellent switch dispenses a measured amount of fluid onto the windshield. Rain repellent should be applied to only one window at a time. Rain repellent may be used anytime the rain intensity requires the use of windshield wipers. This completes the discussion of ice and rain protection.